Hello everyone, I want to welcome you back to Conic section 2. Today we're going to talk about parabolas. We have talked about parabolas in your other previous math classes, Math 1 through Math 3. But you're only familiar with the vertical parabola, like in the top picture. That would be column 1. Those are the ones that either open up or down. The ones you aren't familiar with are number 2. The second column. These will either open to the left or to the right. Now the process for figuring out both of these is exactly the same, and I will step you through it. These are the formulas you're going to need to know. So notice my center is HK for both of them, but if it's a vertical parabola, if it opens up or down, my axis of symmetry is a vertical line in x equals. If it's a left or right parabola, my axis of symmetry is a horizontal line, which is y equals. So this right here is going to be a vertical line, and this is a horizontal line. Now, if you notice both the focus and the directrix, these are two things that are going to help us plot points on our parabola. But if I notice, both of them have a 1 over 4a. So to make my calculations easier, I'm going to take this 1 over 4a, and I am going to represent or use p. So I'm going to say P is going to equal 1 over 4a. That way I only have to do that calculation once, and then I can use it in both of these equations. So just like yesterday, we are going to use completing the square, and we are going to solve parabolas. Where yesterday it was circles, today it's parabolas, but we're going to use the same process. In fact, for every single one of these conic sections, they are all going to start out exactly the same. So if I look down here, I need to zoom out a little bit. So let's look at example 1. So if I look at example 1, the first thing I'm going to notice is I'm going to figure out which one is squared. Since my x is squared and there's only a y, that means I'm going to have to do a y equals parabola. So to do that, we're going to leave the constant and the y on one side, and we're going to move the x's and group them together on the other. So since I have a negative x squared, I'm going to actually move the x's to the right hand side because I always want a positive x in order to complete the square. So I'm going to leave 15 minus 4y here, and that's going to equal x squared plus 2x, and I'm going to go ahead and put my blank because there is no coefficient of x squared. So if I add a blank to the right hand side, I also have to add it to the left. So next I'm going to look at this, and I'm going to fill it out just like I did yesterday. I take my b term, so it's 2 over 2 squared. What I put on one side, I must put on the other. We're not figuring out what the value is, we're just writing it down. So now we're going to go ahead and factor. So this right hand side becomes x, bring down the plus, half of 2 is 1, put a squared on the outside. Now over here, I need to figure out, these are constants, what do they add up to? So 2 over 2 squared is 1 plus 15 gets me 16 minus 4y. So my equation is a y equals, so I need to get it to y equals. So I'm going to subtract 16 from both sides. And I'm going to divide everything by -4. So I end up with y equals, well, when I divide x plus 1 squared by -4, I can't really do anything with that. So what I'm going to do is I'm going to take that and make it my coefficient. So it's really, dividing by 4 is the same thing as multiplying by 1/4. So I'm going to bring it out as a 1/4. And of course it's negative because my 4 is negative. So that's times x plus 1 squared. -16 divided by -4 is a positive 4. So to decide whether it opens up or down, I look at my coefficient of my parenthesis. So since this right here is a negative number, it is going to open down. My vertex. So with the x, I have a 1. Remember, it comes outside as the opposite, so that becomes a -1. And the constant on the side, that's outside of the x, therefore it's with the y. And since it's not in parentheses, we just go ahead and bring it along. So that y coordinate is 4. Axis of symmetry, since this is a vertical parabola, my axis of symmetry is going to be vertical. So it's going to be an x equals, and just whatever the x coordinate of my vertex is, -1. So now what I'm going to do is I'm going to come up here and I need to calculate that p-value because I need to figure out my focus and my directrix, and I need it for both of them. So p is 1/4 times a. A is the coefficient that is in front of the squared term. So that is -1/4. So that simplifies to be 1/-1, which is just -1. So first thing I'm going to do, I'm going to figure out my focus. So my focus is my x coordinate, and I'm just using the formula for from up top. And then it's my k coordinate of my vertex plus my p-value, which was -1. So my focus is a point, so it's the point -1, 3. Okay. My directrix is a line, therefore, and it will always go the opposite way my axis of symmetry goes. So since my axis of symmetry was a vertical line, my directrix is going to be a horizontal line. Therefore, it's going to be a y equals. So it will be y equals, what was my y coordinate of my vertex? 4. And I'm going to subtract my p-value. 4 minus -1, so my directrix is 5. So here we go. To graph this, first things first, I am going to graph my vertex. So I'm going to put a point at -1, 4. From there, I'm going to go ahead and graph my focus. So my focus is the point -1, 3. I'm going to go ahead and graph my directrix. Okay, your directrix is going to be a line, it is going to be a dotted line. So it is the point y equals 5. So from here, I need 2 more points to make a parabola. I have my vertex. My focus is always going to be inside the opening. So what I want to figure out is how far is it from my red dot to my blue line? Okay, my distance between those is 2. So 5 minus 3 is 2. So to figure out points on the parabola, I go up and in line with my focus, my red dot, I go the distance from the focus to the directrix to either side. So I'm going to go 2 to the right, put a dot, I go 2 to the left. Those are the 2 points that are on my parabola. So that is the point -3, 3, and the point 1, 3. I use those 2 points along with my vertex and make a parabola. If you wanted to find more points, you could, but as long as you have those 2 points, it'll at least give you a general idea of the opening. So let's go on to the second one. Here I look and I see what is my squared term. Okay, my squared term is y. Therefore, it's going to be an x equals. Therefore, it's going to be a horizontal parabola. It's going to open left or right. So I want to keep my x and my constant on one side, and I want to move the y's to the other because, again, they're negative. In order to complete the square, I want it positive. So over here, I am going to have x minus 27 equals 2y squared plus 16y. Okay. It has a coefficient. I can't complete the square if it has a coefficient, so I need to go ahead and pull it out. So as I do that, I'm going to go ahead and add my blank over here. So yesterday we were able to divide it out. Today you're just going to factor it out because we can't divide it and get rid of it. X isn't even, 27 isn't even. It's going to make more work in the long run because I'm going to end up having to put it back over on the other side anyway. So I have 2 parentheses y plus, or y squared plus 8y plus blank. Okay, let's go ahead and fill in my blank. So my blank is 8 over 2 squared. Now normally we'll just come over here and we'll put 8 over 2 squared. But my question is, did I add 1 copy of that or did I add 2 copies of that? I added 2, so when I move it to the other side, I need to move what I factored out as well. So when I combine like terms over here, I'm going to get x plus 5 equals 2, and now I'm going to factor it. Factoring it the same way, y plus 4 squared. Next step, move the 5 over to the other side. So I get x equals 2 times y plus 4 squared minus 5. Okay, this time, what's in the parentheses is my y coordinate. Therefore, that's going to be the y coordinate of my vertex, and what's outside is going to be my x, because it's with the x. So my vertex will be the point -5 and -4. Because when it's outside that -5, I just bring it down. The +4, since it's inside a parenthesis, I need to change the sign. To determine whether it opens left or right, I look at my coefficient. That is a positive coefficient, therefore it is going to open to the right. Axis of symmetry, it's a horizontal, therefore my axis of symmetry is going to be a horizontal line, y equals, and I use the y coordinate. So next, let's look at our p-values. So p will equal 1 over 4 times a, and a in this case is 2. So 1 over 4 times 2, that's 1/8. Okay. So to do my focus, this time my focus, my x-coordinate is the thing that's changing. So it is going to be -5 plus 1/8, comma, -4. Well, I'm just going to put that in my calculator, and I get -5. Sorry, not -5. -4.875, comma, -4. So my directrix is next. So the directrix will be an x equals line. So I use my x coordinate. So it's -5 minus my p-value, which was 1/8. That gets me x equals -5.125. Okay. Now, I need to figure out how far this is away from here. Well, since I use p, it is simply, and it always will be, 2 times p. So the distance from the directrix, focus to the directrix, is always 2p. So that is 2 times 1/8, which is 1/4. So that's the amount I'm going to go up or down from my focus. The one thing I didn't graph over here, and I totally forgot, is my asymptote line, or axis of symmetry. That is always going to be, that's going to be a vertical line. It's going to be a dotted line. It goes right through the center of the graph. Where could I fold this graph in half so they would both match up? Okay. So let's get back to our last graph. So I need, first things first, I'm going to plot my vertex. So I'm going to plot -5, -4. Okay. From there, I'm going to plot my focus. So that is really, really close to it. Okay. I will also plot my directrix, which is right on the other side of it. Okay. Your parabola will always go around your focus, and it will always go away from your directrix. So to find my other 2 points, I'm going to use my distance from the focus to the directrix, or 2p. That was 1/4, so I go 1/4 on the side of the green dot, which is my focus, and then I connect the dots. Okay. And again, I'll graph my axis of symmetry, which is the line right in the middle. It goes right through my directrix. If you have any questions, please email me, call me, and I hope this helps. See you guys soon.